Hey everybody, this is Mr. Diamond, and we're getting ready to do our introduction to Chapter 1 of Organic Chemistry. This first video is going to be really short because it's mostly going to be the review stuff. Then I'm going to get into some quantum numbers and then a little bit more into some of the bonding stuff that we're going to talk about. That bonding video is going to be like the longest one for sure though. So first let's get this out of the way. This is Chapter 1, Structure and Bonding. As you're probably going to learn pretty quickly in this class, most of what you learn in general chemistry is either useless, incorrect, or some combination of both. For example, here is basically the organic chemist's periodic table. You've got, if I get my little pointer here, you've got carbon, the most important thing, carbon's little buddy. Make sure you don't get them wet. These guys are boring. These are all catalysts to do actual stuff. These are all fake elements made up by commies. Who cares? Weird. We use these to make nukes. These are all things that we discovered here in America, named after some smart guys. These are heavy. We need these to live. These are okay because they also buddy up with carbon. These make thermometers, batteries, coins. These are the ones that are worth a bunch of money, and these guys are all lazy. And then helium, I guess, makes up the sun. But carbon is the best. Carbon is the thing we care about the most. So this is actually a pretty accurate representation. There's only a couple of elements that organic chemists really usually care about, and most of it's focused on carbon's special little buddy, these guys right here, and then the halogens right here. But first we're going to do a little bit of review just to make sure we're all on the same page. I'm sure you guys know all of these, otherwise you wouldn't have taken this class. Atoms compose all of matter. They're made out of protons, neutrons, and electrons. I know, yeah, we can go and get to like quarks, leptons, and gluons and stuff. We're not going to do that. Protons and neutrons are in the nucleus. We also call them nucleons because, you need more vocab terms. There's not already enough of those. And then electrons orbit around the nucleus. They aren't in consistent patterns. They are in clouds of probability referred to as orbitals. And they act as both a particle and a wave. Now, I don't know if we talked really about that in either your chemistry class or if in my chemistry class or whatever, but it's not going to be super relevant to what we're talking about here. I'll explain all the stuff you really need to know. Most atoms are attempting to become as close to a noble gas as possible, and it's going to do this by either gaining or losing electrons to try to fill an octet. We're going to talk about why that's a little weird in a few moments. And then this process of gaining and losing electrons is what leads to the formation of compounds. Geometry of molecules can be determined by looking at the attached components and at the electrons that are present. At this point, it's just kind of do you need any more clarification on any of this? So any of this stuff that we're talking about here in the next couple of slides, if you feel like you're going to need more clarification or you want me to make a video explaining something in more detail, please put that in the comments of the assignment or send me an email for it. As for bonding, there are ionic bonds and covalent bonds. Ionic bonds involve the complete transfer of electrons from one substance to another, usually a metal and a nonmetal, or will involve polyatomics. So Na and Cl will bond together. You will get sodium chloride. And then covalent bonds are what we're going to use more in this class, and these involve the sharing of electrons. Usually going to be nonmetals. Things like carbon monoxide and water are held together by covalent bonds. And then we're going to talk about orbitals. This is going to become much more relevant later on. And I know this was early in my version of the class. Orbitals refer to an area where an electron can be found about 90% of the time. We don't know for sure. It's in here 90% of the time, but it could also be literally, it could be in Kansas for all we know, because probability and quantum mechanics and stuff works really weird. And then orbitals can be found on varying energy levels and in various orientations. To use these, or to identify these, we're going to use quantum numbers. Now, I know it says, do you know this already? If not, we'll discuss them briefly. But this year, I do know, in fact, that you guys do not know this, so I will be discussing them here. First of all, just as a refresher to go through here, we've got our s orbitals, which are just spheres. P orbitals, which are these dumbbell-shaped, and because they're dumbbell-shaped, a sphere you can only hold in one space. No matter how you rotate it, it's going to take up the exact same amount of space. But if you have something that is dumbbell-shaped, let me reach over here and get a pencil I can use. You can orient it up and down, you can orient it side to side, and you can orient it in and out. So it's three possible orientations that you can actually position it, so you can fit three p orbitals on one energy level. D orbitals get even more complicated. You can fit 5 of those, and then F orbitals are even more complicated than that. You can fit 7 of those. Each orbital can hold 2 total electrons as well. So that was kind of just some background introduction stuff. I wanted to make this its own day so you had the chance to think on this, and if you need anything for me to go back and reflect on or to ask more questions about, you have your chance to do that. So again, leave questions if you have them. Tomorrow we're actually going to have a video where we're going to get into quantum numbers and quantum mechanics stuff. So let me know if you have questions. Otherwise, have a great day.